So, Chapter 9, Lesson 6 is area of composite figures. First thing we want to do is it says, what is the definition of a composite figure? So here, a composite figure is a figure made up of two or more dimensional figures. Secondly, number 2 says, explain how you can find the area of the figure on the left. So, just like you said, we will separate them into different pieces, and then once you separate them into different pieces, of the that you know the formula of the pieces, then you find the area of them and then you add them together. So we are going to find the area of a composite figure. You can decompose some trapezoids into a square and a triangle to find the area. Now, decompose is one of the vocabulary words. It's actually not a vocabulary word, but when they say decompose, all they mean is that you're breaking it into the pieces. Okay, so you're breaking it down to the pieces. That's what decompose means. So here we have an area of a square and the area of a triangle. So once you decompose the composite figure, then you can find the area of each of the pieces. When you do that, then you can add them together, and then you have the area of the entire figure. For example 1, it says find the area of the figure at the right. The figure can be separated into a rectangle and a triangle. So here, what we're doing to decompose this, we are just going to break it right across to create the triangle, right? Now, when you do that, you also have to figure out the dimensions, okay? So we know here we've got the dimensions of the rectangle, the length and the width, but then up here we have the height of the triangle, okay? But we also need the base of the triangle. So how can I figure out what that base is? So we're going to have, to get this base, we're going to take that 10. We know it's 10 because it's the base of the rectangle. And then up here, right, part of the top of the rectangle is 6, but we only want the piece that includes the triangle. So we have 10 minus 6, and that gives me the 4 inches. Very good. So once we know all of our dimensions, then we can write our formula, substitute, and simplify to find the area of each one of the figures. So here's the area of the rectangle, and here we have the area of the triangle. Now, here you'll see the area length times width. Now, yesterday we called it base times height. Same thing, okay? Same thing. Let's do this got it together. So here we want to find the area of each figure. So for the first one, how would you break that up? Yes. All right, so here you can decompose the figure by separating it into the triangle at the top and the rectangle at the bottom. Okay? So now we know the formula for the area of a triangle, and we know the formula for the area of a rectangle. So the formula for the area of the triangle is 1/2 base times height, and the area for the rectangle is length times width. Now I would like to call these, let's call this area 1, and let's call this area 2. Okay? So now we can substitute in. And of course this is the triangle is area 1 and area 2. You got to make sure you label your work, okay? So we have 1/2 times the base. Now, what is the length of that base? Yes?
12 minus 8.
Very good. So 12 minus 8 is going to give me 4. Very good. So times 4. Now, how about the height? What is that going to be up there? Yes?
10 minus 4.
So here, 10 minus the 4, which is going to be Very good. So we have 1/2 times 4 times 6. Now when we simplify, we can do 1/2 of 4, which is what? 2. And then 2 times 6 is 12. So we've got 12 feet squared. Okay? So next we can find the area of the rectangle. So here's the length, there's the width. So we have 12 times 4. So the area of the rectangle is 48 feet squared. Don't forget to put your units, right? Feet squared. And then to find the total area, we just add those together, right? So the total area, so I put AT for total, is equal to area 1 plus area 2. So area 1 was 12, and this is how we're going to write this. We're going to write 12 here, plus area 2, which is 48. And when we simplify that, we end up with 60. Very good, feet squared. So how about the next one? How would you break this one up? So here is how we're going to break it up. Right. So let's call this area 1. Let's call this area 2 and area 3. Okay? So area 1 is a rectangle. And I believe that's this one, okay? So there's the area of the rectangle. Then we have the area of a triangle, that's area 2. There's area 2. Make sure you write down your formulas. And then we have area 3, which is a rectangle again. Okay? So we've got areas 1, 2, and 3. Okay? So, for area 1, what's going to be the length right there? What's that length going to be? Yes. So, that length is 5 because it's right there. And then we want to know what is the height of this, or the width of this rectangle. So how am I going to find that one? Yes. 10 minus 7. Very good. So this is going to be 3. Very good. So the length is 5 and the width is 3. So the area of area 1 is 15 meters squared. Okay? Then for the triangle, we have 1/2 base times height. So we already got the height right there. How do I figure out the length of this base right there? Yes.
That's 7 minus 5.
Very good. 7 minus 5, so that's going to be 2. Got it? So we've got 1/2 times the base, which is 2, times the height, which is 3. So when we simplify, we can do 1/2 of 2, which is 1, and then 1 times 3 is 3. So that's 3 meters squared. And now we can find the area of area 3. So length times width, that's a simple one, right? We've got 7 times 7. So that's going to be 49 meters squared. And now, to find the total area, we just add them all together. So now, to find the total area, we're going to add 15 plus 3 plus 49. And what's that going to give us? 67 meters squared. Very good. Okay, for this example, you don't have to write this one down. Area 2, it says, let's see, example 2, we are going to find the area of the pool's floor. Now here it says separate the figure into a rectangle and a trapezoid. This is where you're going to be introduced to the formula for the area of a trapezoid. Here it is right here. They did the substitution. They did the substitution already. The formula for the area of a trapezoid, make sure you write this down, is area is equal to 1/2 times the height times the sum of the bases. So when we find the area of the floor of this pool, we have the trapezoid right here where the stairs are, and then we're going to find the area of this rectangle, and then we're just going to add them together. Okay? So let's do this one down here together. So we've got the area of a trapezoid. So for example C, we want to break this into 2 pieces. Okay? Now this 20, this dotted line right here is just telling you, okay, actually I think the book wanted you to break it up here, but I think there's a better way to break this up. Rather than in 3 pieces, we can break it into just 2 pieces. So here, rather than breaking it into 3 areas, we're just going to break it into the top trapezoid and the bottom rectangle. Okay? So, all right, so the first thing we want to do is find the area of the trapezoid. And let's call this area 1. And then the rectangle, we'll call it area 2. Okay? So the trapezoid, area 1. So we've got 1/2 times the height of the trapezoid. What is the height of this trapezoid? Yes. Good. So to get this height of this trapezoid, we would do 20, which is the whole thing, minus the 14 down here. So 20 minus 14 is 6. So the height of the trapezoid is 6. Okay? So now, so we've got 1/2 times 6 times the sum of the bases. Now in a trapezoid, the bases are the parallel sides. So you know that this one and this one are not parallel, right? So that means the base is this one and this one. Is everybody clear? So what am I going to add for my 2 parallel bases? 20 and 36. Very good. So this is going to be 20 plus 36. And now we can simplify for the trapezoid. So 1/2 of 6 is equal to 3. And then we're going to multiply that times 56. So 3 times 56 is equal to 168, and of course it's feet squared. Feet squared. Okay, so now we can find area 2, which is the rectangle. Okay, so area 2, to find the rectangle, what am I going to multiply? What am I going to multiply for the rectangle? What times what? Pretty simple. Yeah.
14 times 36.
Very good. So the length is 36. The width is 14. And when we multiply that, we end up with 504. Very good. And that's feet squared. Now, to find the total area, you add them together. Very good. So we are going to add 168 plus 504, and we will end up with 672. Very good. And that, of course, again is feet squared. Beautiful. All right, so finding the area of overlapping figures, okay? Now here, this is like, let's say we're finding the area of this first square right there, right? And then we're going to find the area of this square right here. What do you notice? There is an overlapping piece right in the middle, right? So that piece in the middle was counted twice. You see that?
Yeah.
So we need to take one of them out. So we have to take the area, find the area of that, and subtract it out once. Is everybody with me? Okay. So that's how we've got the area of the top, the blue triangle up there. It's 144. We have the area of the red, not triangle, rectangle. Area of the red rectangle, that's 180. And then we had to find the dimensions of this middle part. And you know how to do that. So now you have to find the area of the middle piece. And here I've already done the dimensions of the middle piece. So we use the 12 minus that 6 up there, gives me this width. And then down here we have 15 minus this 8 over here. That's going to give me that 7. So to find the area of this middle overlapping piece, that's how they got the 6 times 7, which is 42. And that is what you're going to subtract. Okay? So let's go ahead and try this one together. So the first thing we're going to do is we're going to find the area of our rectangles. So we've got, let's call it area 1 and area 2 again. And we're going to multiply length times width. So for area 1, we've got 6 times 8, which is 48. And again, this is feet squared. And then for area 2, we have 6 times 7. And that's going to give us 42 feet squared. So now we add them together. So we are going to add area 1, which is 48, plus area 2, which is 42, and that's going to give us our total area. So that's 48 plus 42 gives us 90 feet squared. Okay, so now we need to find the area of this overlap and subtract it from that total. Okay, so the formula for the area of the overlap is length times width. So the area of the overlap is length times width. First we have to find our dimensions. So let's see, we've got this 6 minus 1, so that's going to give us this, which is going to be 5. So that's going to be 5 right there. And then we've got the 7 right there. And then we're going to subtract out that 2 up here. So 7 minus 2 is going to give us 5 again. So there are the dimensions for the overlap. So the overlap is the 5 times 5, which is 25 feet squared. And now to subtract the overlap. So the final area is equal to the total area, which is the 90 feet squared, minus the overlap. Let me fix that. So it's the final area is equal to the total area, which is the 90 feet squared, minus the overlap. So here, to get our final area, we've got 90 minus 25, which is equal to 65 feet squared. And finally, example 4 is just like the overlap example. Here it says Charlie and his brother Matthew are neighbors in an apartment complex where they share a patio. We want to know what is the area of both apartments and the patio. So on this one, we're going to find the area of Matthew's apartment, then find the area of Charlie's apartment, and then of course we're going to subtract out the area of that patio that was counted twice. Okay, so if you look here, the area of their apartments are the same. So each apartment is 2,475 feet squared. There's 2 of them, so together the total area is 4,950. Then we want to find the area of the patio, which is 23 feet times 23 feet, and that is what we're going to subtract from the total to get our final area.